Hello everyone. In this video, we will learn about Bayes formula. This is a formula that we will need to use sometimes when we are trying to find conditional probabilities. Okay, I'll start with this example. The probability tree is given, and we are looking for probability of probability of A given B. Well, the first thing you have to notice here is that, well, the labels of the edges here starts with probability of A, and then in the second level is probability of B given A. And as you check this, you notice that, oh, there's something strange about this probability that we are asked to find. The order of the events here is the other way around of the order of the tree. You see, the given part, the known part, is coming from level 2, while we are looking for probability of an event from level 1. But on the tree, the conditional probabilities that we can find are the other way around. We are looking usually for probability of an event in a second level, knowing something happened in the first level. But, well, what can we do based on the given tree? Here we go back to our old friend, the formula for conditional probability of A intersect B, and probability of B itself. But these are the probabilities that we can use the rules of the probability trees, and find them based on the given information. For example, probability of A intersect B, we have to find a path which includes both A and B and find probability of that path. In this case, this is 2 over 4. Let me clean up these words here, and as you see, well, this must be 3 over 2. That's the total must be add up to 1, yes? So 2 over 4 times 2 over 3. How about probability of B here? Well, there are two paths which end to B. So we have to find probability of each one. The probability of first one we already found. The probability of the second one. Here I have to find the probability of this path here. Well, as you can see, this must be 2 over 5. So I have 2 over 5 times 1 over 3. And then we add these two numbers. Well, we can calculate these values and simplify those ones. Let me just do it here as I can do more a little bit. 1 over 3 will be in the numerator, 1 over 3 there, plus 2 over 15. And that will give me 15. 5 plus 2 is 7 over 15, and this is 5 over 15. I can cancel these two. This is 5 over 7. This is what we have used here, which seemed that it's very straightforward, and we did just start with the formula for the conditional probability, but basically what we use there is called Bayes' theorem. So let me then write down what is Bayes' theorem and when we use that formula. Before that, maybe I should tell you when to use that formula. If the order on the conditional probability is the reverse, or is the reverse of the order of the tree. In other words, we are looking for, some people put it this way, we are looking for cause given effect. Usually cause is what is happening in the first level, and the effect is what you see in the second level. But if you change the order of these ones, then you are going to deal with a different kind of probabilities. And these guys, these probabilities, if the order, we cannot find on the tree. So the probabilities of this form cannot be found on the tree. But okay, then there is a way to do that. It's called Bayes' theorem or Bayes' formula, which I will write it down. It may look a little bit complicated, but I'll tell you just what does it mean when you work with the trees at least. So let E1, E2 up to En be a partition of the sample space. Sorry. It means that they are mutually exclusive and their union form the whole omega. Then probability of any event E, probability of any of these guys knowing E is going to be given by probability of E knowing EI times probability of EI. And in the numerator, we go from probability of E knowing E1 times probability of E1 and add these guys up to probability of E knowing En times probability of En. Well, if the order of the cause and effect is different than the tree here, on the right hand side, if you note, we have changed all the orders. So these are the ones that we have on the tree, so you can pick these numbers from the tree and calculate that probability. But well, as I said, this may look very complicated. However, what you need to know is that when we are trying to find probability of cause given effect, it's enough to start with the formula for conditional probability, and find numerator and denominator using the rules. Find the related probabilities using the rules. In other words, if you're looking for probability of EI knowing E, you just write this one. The order is not the order of the tree, so you start with this with this formula, which is in general true for any conditional probability, and then go find this value, find all the passes which includes EI and E, and find all the passes which includes E, and then divide those guys. And first find probability of each path, add them, and then divide these two values. That is basically what this formula will give us. Okay, so let's do an example here. There are two identical urns, and they have blue and red. Urn A, so we have urn A and B, then we have red, not red, so better to write it like that, and red and not red. Okay, so urn A contains 5 blue balls and 2 red ones. So in total there are 7. 2 of them are red, so this will be 5/7. For B, another urn, there are 4 blue and 4 red, so this will be 4/8, which is just 1/2 and 1/2. One of these are chosen at random, meaning that they will have the same chance as being chosen. And now the experiment is done. We are looking for probability of a blue, which is red complement, is and we know that a blue is drawn, so red complement is known. Now what is the probability that we get this the ball from the first urn? Okay, so you see that the order is the other way around. We know something from level 2. We are trying to find probability from something from level 1. So this is probability of A intersect R complement over probability of R complement. So probability of the intersection of A and R complement is given by this, half times 5/7. Probability of R complement itself is given by these two paths. So the first one is half times 5/7, plus the second one is half times half. So this way we have 5/14, 5/14 plus 1/4. The common denominator, I will make everything 28. So this way we have 28 down there, and 10 plus 7. And these two cancels. This is 10/17.